Good evening, students. How are you doing today? Good evening, students. Osh, I understand exactly what you're talking about here. All right. So Tristan is still in traffic. Is everybody home already, or are you still in commute? Anybody else is ready? All right. I'll give you guys 5 minutes more. All right, guys. 7:30, please. I have posted a question as a do know. I gather that some people are still on their way in. Let us work until and give this one your best shot before I move into my new topic. Remember, I'm starting a new topic tonight. Sorry, I shouldn't say it like that. I'm starting and finishing a new topic tonight. All right.
Good
So I'm
night.
giving you good night, my dearest. I'm giving you 5 minutes to work this question. So I'll leave you alone for the next 5 minutes to work the question and then I'll come back to you. How are we? Are we okay?
I'm just trying to start something.
I think I get some, I'm not sure about it. And when I'm done, no, it's one again.
Say it again, Oliver. You say what?
I think I get A and B, but I'm not sure, so I'm waiting when I'm done.
No, but check it. No, Oliver, check it. If you get A and B, you can check it, you know. Put in the value for A and put in the value for B and check to see if the left and the right hand side is continuous. You can check your answer, man. Check it in the meantime. I'll give others a few more minutes to finish off that. But check it, man. All right, come guys, come talk to me. Are you all finished now?
No, sir.
Working strongly, man. Come on. I don't want to do it yet because I'm giving you a mid-semester next week. We can discuss, since both classes are 79, we can discuss tonight which of the days you want to have it. Because as I told you, I'm starting and finishing one topic today. And this topic is going to come on the mid-semester. So you have to get this piece out of the way so that you're ready for the mid-semester. So should I give it 3 more minutes, 4 more minutes, 5 more minutes? What it is?
5, maybe, or 3.
5 more minutes. Oliver, did you check your answer? Oliver?
I actually see where I made an error, so actually corrected it.
All right, then. Look back at it. How we stay now?
Stop. Can't go no further.
What about the rest of you? Chevy, how you stay? All of I finish it?
Still working, sir.
Hmm?
Yes.
What is that, Chevy? Chevy, what you saying?
I'm saying I'm still working.
Okay. Oliver, what you say now?
Yes, I completed it. To find out my error and fix it.
Did you double check your answer? But I mean, when I say double check,
No,
I
not
mean,
as I'm gonna put it in now and see if it's correct.
yeah. So put it in. When you put it in, the value of A and B, run the limit one more time to see if you get the limit to be continuous both ways, if you understand what I mean. So when you do it, let me know, just let me know that you've done it, and tell me if it works. I'm just trying to show you some shortcuts, how to check your answer, that is. All right, I give you 2 minutes. Hurry up for me, Chevy. Sabrina, how far are you? Simon, Tristan, how far are you?
Sir, I'm still trying to figure out the simultaneous equation.
The simultaneous equation. Okay. Sabrina? Oh, Sabrina gone. Tristan, how are you doing? How far are you reach? Oh, by the way, are you still in traffic, Tristan? No answer.
Tessie on the right.
Okay. Oliver, did you substitute?
Yeah, man, and you're right.
So I'm gonna tell you, so when I do it, you must tell me, Virgin.
Yes, I did.
I know, but I mean, I'm here waiting for you to say something to me.
No, I did say something, but nobody never responded to me.
Oh, all right.
So he did.
All
You
right. So
probably was wrong.
say it again.
I'm saying he did responded. You probably weren't in front of the computer.
No, no, no. I have not moved from my computer class. I'm in one position, but I didn't hear. All right. So, out of path. Where am I? Let me get a new share. Is that the question?
So what you just said?
I was asking if that was the question that I gave.
Yeah.
So let me show you something before I even move into the question. Let me show you before I even move into the question. These two questions are saying exactly the same, are asking the same thing. Clearly, you can see that the first equation up top is the same. You can also see that the last one is the same. I'm just proving this point. Ax over 2 minus b is the same thing as saying a over 2x. A over 2x. So this and this is exactly the same thing. So ax over 2 is the same thing as a over 2x. Get that? Hello?
Yes.
All right, cool. And then we're checking the limits to the left of 2. See here? It's less than, so it's to the left of 2. So anywhere, so I'm going to have the limit x tends to 2, it's superscript minus because it's to the left of 2. And anywhere in the function, I see x, I put 2. So this is going to be 2 times 2 squared, see it right here? Minus 3 times 2, minus 1. 2 2 is 4, 4 2 is 8, and 3 2 is 6. So this is 8 minus 6 is 2. 2 minus 1 is 1. All agreed with this one?
Yes, sir.
Yes, sir.
Mhm.
Yes, sir.
And then now, we're looking to the right of 1. Of 2, sorry. So to the right of 2, I have to use this equation. But in order for the function to be continuous, this here must be equals to 1. And I make my substitution. So
Yeah, sorry, just step away for a moment. I'm back. Sorry.
yeah, you got 1 for the first one to the left of 2?
1, yes.
Great. So what I'm saying to you now is when we're investigating this to the right of 2, whatever works out to be the right of 2 has to be equal to 1. Why, sir? Because the function is to be continuous. You're trying to find the values of a and b to make this function continuous. So that's why you can't do the second piece. You can't do to the right of 2 first before to the left of 2. This piece cannot be done before this piece because I don't know what this is going to be equal to. So when you do this calculation and you get your x equals, your limit tending to 1, it means that in order for this function to be continuous to the left and the right of 2, and for it to be a good behavior, the value to the left must be equal to the value to the right. So therefore, whatever this is, this must be equals to 1. Can you see that?
Yes, yes, you can see that.
And then now, I can't do the second part. I can't do to the left of 5 yet. I have to do to the right of 5 first. So when I look to the right of 5, this is going to be x tending to 5 plus, see it up here, so. Anywhere in the function I see x, I put 5. So it's negative 7 plus 2 times 5. 2 times 5 is 10, minus 7 is 3. Now I'm going to go back to this one, because in order for this function to be continuous, any number this limit is tending to has to be the same number it's tending to here from the right, from 5, from the left. So I'm going to say from the left of 5, see here, 5 superscript negative, so just saying it's to the left of 5. I'm going to make the substitution as 2 times 5, I'm sorry, because it's tending to 5 minus b, and it has to be equal to 3. What I'm saying to you is that this your number and this your number must be the same. Similarly, this number and this number must be the same in order for it to be continuous. So what I'm going to have here now is going to be 5 over 2 minus b equals 3. And what I'm doing, in order to get rid of this fractional form, I'm multiplying throughout the equation by 2. Why, sir? Because 2 is in the denominator. 2 is in the denominator, so I'm multiplying by 2.
That's where
To
I
get rid
stop
of it.
from, sir.
That's where you stop?
Yeah.
Yeah, man. So that's what we needed to do. Just to multiply by 2 in order to get rid of it. Do you agree with my step though? My reason right there, right?
Make it easier to work with. Yeah.
Yes, sir.
Yeah, man, it makes it much easier to work with. All right. Incidentally, Oliver, congratulations. I really like your progress. Okay.
Thank you, sir.
Yeah, man. And then now, charging. And then now, when I multiply by 2, I'm going to just be left with 5a because this 2 will cancel. So I'm going to left with 5a. I'll multiply this by 2, we're going to get negative 2b. Multiply this by 2, I'm going to get 6. So my equations are similarly if x is equal to 2 here, a times 2 is 2a divided by 2 is going to be a. And let me put another line in here because I don't want you to not see what I have. So I'm making a substitution of this x to be 2. Why, sir? Because it's tending to 2. Why I made a substitution here to be 5? Because this here is tending to 5. So these two cancel. Those two cancel. So I'm going to be left with a. So I have my a there. Minus b equals 1. So the two equations in blue are what I'm going to be using as my simultaneous equations. Simon, you see that now?
Yes.
And you agree with it?
Yes, sir.
All right. I'm pausing there for one moment. I'm pausing for one moment. Is there somebody in the class that is not seeing what is happening there? Hmm? Are you in agreement? But if they don't talk to me, how am I going to understanding?
Yeah,
You
I'll
answer
answer
question.
faster.
I ask a question and nobody not answer me. How can I think that?
Sorry, in agreement, but I wouldn't get there.
You will get there on your own?
Yeah.
All right. So that's why I'm spending the time to look at this stuff, because it don't make sense I run through the syllabus and I run another gun and don't understand one thing that I'm doing. But guess what I'm recognizing though? I'm discerning something. And what I'm discerning is you guys are not putting in the work. You're not putting in the work. And therefore, when I come back to class to do a revision, the deficiencies are showing up. So you're coming to class, and you're understanding what I'm doing. Without a shadow of a doubt, you are understanding. However, you're not putting the information to long-term memory. You're just using your understanding for what happens in class and think that is it. Wrong. This is not POB or social studies or office administration. You have to practice it to send it to long-term memory, or else in serious trouble. So now, when I solve this simultaneously, what I'm going to be doing is, as I indicated here, I'm multiplying equation 1 by -2. Why, sir? So that I can eliminate my b's. So now multiplying equation 1 by -2, and we'll have -2a. Negative b times -2 is positive 2b, right here. And 1 times -2 is -2. No, I'm forgetting about equation 1.
Where came from, sir?
Say it again, my love.
Where -2 came from?
I am using -2 because I am
Because you solve the
trying to
minus
eliminate the
five.
b.
Oh, so I could use -5 or -10?
You could use -5 to eliminate the a's.
Oh, so 2 or 5 because we're working 2 or 5?
Look at the equations. Look at the equations.
Okay, sir.
Mm-mm.
I
No,
see.
no. Oh, you see it? Okay, okay.
Yeah.
No, it's just that I don't want you to think that I'm saying I'm not responding to you. Just look at the question. No, that's not what I'm saying. I was asking you to look at the equations to see that equation 2 is 5a and equation 1 is just a. Now, in order to eliminate the a, both equations must have the same term for the ones that you are trying to eliminate. So if I'm trying to eliminate the a's, equation 1 must have a 5a and equation 2 must also have a 5a. And in that case, if both of the signs are the same, I subtract. If the signs are different, then I add. So I decide, so if I want, I could multiply equation 1 by 2, But if I multiply equation 1 by 2, what would have been my operation in order to eliminate?
You said if you multiply by +2,
Mm-hmm.
you have to add them.
Subtract.
Wait, hold on. So, oh, yes.
Because this will be a -2 and -2. Now, in order to eliminate
yeah,
that, I have to
the
subtract one from the
minus
other.
and minus here plus, yes.
Right.
Sorry.
Mm-hmm.
Yeah. Minus.
So that's what it is. Now, when we add 5a minus 2a is 3a. Minus 2b plus 2b is 0. And 6 minus 3 is 4. So a is going to be now 4/3. A is going to be 4/3. You agree, Oliver? That's what they got. That's what they got.
Yes.
Oliver,
Yes.
that's what they
Hello?
got. That's what they got.
For A,
For
I got
A.
4/3.
Nice. And now, the value that they got for A, you're going to substitute it into
Can plug
any
it
one of the
into,
equations.
right. That's what I did.
So I'm using equation 1. I'm using equation 1. So equation 1 says A minus B equals 1. But A is now 4/3. So now I'm going to say 4/3 minus B equal 1. Uh-oh. Uh-oh. What I'm going to do is to transpose so that I can get B to be positive. So I'm going to subtract 1 from both sides, and I'm going to add B to both sides. So it becomes this. Now, 1 is the same thing as 3/3. 1 is the same thing as 3/3. Or you
Yeah,
find the
1 is
LCM.
3/3. Yeah.
Yeah, man. So you have 4 minus 3 is going to be equals to 1, and you put by the denominator as 3. So B is going to be equals to 1/3. And those are, and that will be the solution for your answer, for your question. Really not difficult, you know. But what I figure, what I discern, and I'm not accusing you, but it's a strong discernment. You guys are not putting in enough work.
Where I made my mistake is in the section
And that's,
there
uh-huh.
where you had 5/2A, and then I substituted in A minus 1. I kind of want to forget the minus 1. So that's what I made mistake. I'm not look back and realize the mistake and fix it.
My screen gone?
Yes, screen gone.
Oh Lord, what happened right here?
You can hide some super secret method from.
No, sir. I mean, I'm using a computer, it just, well, it's back up, but I don't need to go back now to Zoom. It just, oh, that's what happened. I got disconnected from Zoom. Got disconnected from Zoom on the computer. Give me half a second. Let me go computer back. All right. Talk to me. Ask me your questions to clarify. You getting it next week? Clarify it now. I'm spending 5 more. I'm starting and finishing a new topic tonight. You know? I'm giving you 5 minutes more to look through the question, to ask me any questions you have, so that I can clear it up. And at 8:26, I'm moving on.
Sure, you just want to give her another one.
For homework, because I have to move on to the new topic now. I can give you another one for homework.
All right.
All right. I don't even think I can. All right. I did a summary something here. Look at this summary. Matter of fact, read through the summary on your own. Tell me if I captured the summary correctly, and tell me if it makes a difference in you understanding what is required of you. Go.
It's about this algorithm, man. Mr. Sean.
But is used in a good way, right?
Yeah, man. All nice piece of algorithm.
Nice. Yes, I think so too. I agree. All right. I now need to find my topic for tonight. Got you. I want you undivided. I want to make sure that you are where you're supposed to be. I hope you put the children them to bed already. You lock off in a room. I need about 10 minutes, 10 to 15 minutes undisturbed time from you. Once I do this just once, you should be good to go. Should be good to go. Incidentally, today is a rough day for me, or has been, because early this morning I had to travel down to Knoxcombe College down in Clarendon. Yeah. College Mandeville, Cobbler campus. And we were sitting together as lecturers putting your final exam paper together. No. If I were you, you will come to my class and you will pay special attention. If I were you, come to my class and pay special attention. Everything that I've taught you so far, you should be able to answer on that paper at this minute. At this minute. And I guarantee you that the other areas that I'll be teaching you, you'll be in a good light to pass in the exam. Focus. Differentiation from first principles. Differentiation from first principles. So you will go into an exam for argument's sake, and you will see them say to you in the exam, differentiate. And they give you the function, and then issue up something in the question to say from first principles. If you use any other method other than first principles, you're wrong. if the man them just said differentiate, and I tell you which one to use anything you want to use. But from the man them say ropes, that you have to do. That you have to do. So let's go. The prerequisite knowledge for this topic is going to be algebra. The prerequisite knowledge is going to be algebra. If you don't know your algebra, you cannot dark. Darker than midnight. Have to know your algebra. Let's go. It says to differentiate 2x squared minus 5x plus 3 from first principles. Differentiate 2x squared minus 5x plus 3 from first principles. Not a problem. Really and truly, it isn't a problem. Let us go. In order for you to use first principles, we must apply this formula. The limit as h tends to 0 of f of x plus h minus f of x all over h. The limit as h tends to 0 of f of x plus h minus f of x over h. Sir, what that? Thank you for asking. So, you're working in the hotel industry as a food and beverage manager. And you're doing a nice cream of pumpkin soup. But while you do the cream of pumpkin soup, you recognize you have to go put your scallion and your garlic and your thyme and your pimento. Some people may put cloves in there. Some people may put parsley in there. Some people may put, you name it, whatever else I put in there. But when it cook up, you're going to see the thyme leaves on top. You may have one piece of scallion in there. That's one of the worst things for me. I drink my soup and buck up one piece of scallion in my plate. If you let me know I eat no more soup. Turn off. In the hotel, you can't do that. Every bit of seasoning you put in the pot has to be removed. So you don't know the man them do. The man them have like a locket. And in this locket, they put all of their seasoning in the locket. And as it suggests, it's a lock. So it's like a strainer, it's like a metal strainer you have. But then put two metal strainers together, make them kiss. And there's a hook to it. And then take out the handle of the metal strainer. So it looks like a ball now with a chain on it. And then just drop it in the pot and hook the chain onto the side of the pot. And the pot up boil, you know. And the seasoning them are work or something, you know. To go on good. Now when the food done, you just unlock, you just remove the locket. And you'd have removed every bit of seasoning that you'd have used. Then, sir, how that come into it? Thank you for asking. You see this H? That is my incremental change. That is my seasoning. The one here. That is my seasoning. So I'm putting it into the stuff so it is that it can work its magic and give it a nice flavor. But in order now for me to see the final product, I'm removing my original stuff from it. So what is left is going to be that change. So when I differentiate, I'm finding the rate of change of one variable with respect to the other variable. I'm finding the rate of change of one with respect to the other. So when I subtract my f of x, it means that whatsoever is left will be my incremental change. Because I would have already taken note from what it is that I have. Remember, I would have had f of x plus h. then I'm going to, when I do the f of x plus h, when I look at my incremental change for each of the term in the function, then I'm going to go back into the question now and remove my function in its entirety. Meaning now, all I will have left is just an incremental change. All I will have left is just an incremental change. All right, sir, let me see. All right, thanks again. So look at what is happening. So every time I call a x, I'm going to put a plus h. See it here, so x plus h. Why, sir? Because I'm trying to investigate what change will occur when I put an increment to this function or this term. So the limit as h tends to 0, 2, good, you write him back. Uh-oh, there goes a x. It has to be x plus h. But x is square, so the x plus h is going to be all square. See here? X plus h all square. So if you look at it this way, all of this could be considered x. So you could have 2x squared. See here? 2x squared. But your x is going to be to an incremental change. Watch this one. This is minus 5x. So it's going to become minus 5 times x plus h. See it right here, so minus 5 times x plus h. Why? Because every time you call it x, you are going to be adding that incremental change to it. What is the incremental change? That is going to be h. We are trying to find the limit as h tends to this 0. What is happening? And I will tell you a little later on after the topic how differentiation becomes very important and very useful. Matter of fact, I'm going to tell you, when we see it, when we start in the course, and even more so in calculus 2, when we start looking at applications to differentiation. All right? Now, there is no x really for me to do a substitution at the 3, so my 3 goes back as it is. And then remember, now I need to minus my f of x. So it's going to be minus, see f of x here is going to be minus all of this, 2x squared minus 5x plus 3. See here? 2x squared minus 5x plus 3. What I have done is to subtract my f of x in its entirety. So if you look at the question, you recognize the question is 2x squared minus 5x plus 3. And what I'm taking out is a 2x squared minus 5x plus 3. One or two of you may be looking out to say, sir, then why have this one right here? I'm going to show you shortly. You know, I put it in blue because I want you to see it. All right? So I have my incremental change. Then I'm removing my function in its entirety. And of course, it's divided by h. Now, recall, x plus h all square. We did that pretty recently. X plus h all square is the same thing as x plus h times x plus h. Talk true.
Yes, sir.
Sure.
Yeah. So when we're expanding x plus h times x plus h, I want you to see what we get. X plus h times x plus h all squares is the same thing as x plus h times x plus h. Watch this. X times x is x squared. X times h is hx. H times x is hx. And h times h is h squared. There's only one x squared in this expression, so I write it back. But there are two hx in it, so I'm going to add them together. One hx plus another hx is 2hx. And there's one h squared right here. So I'm going to put the h squared there. So what I'm saying to you is, my expansion x plus h squared is going to be equivalent to x squared plus 2hx plus h squared. I'm making that substitution here for the x plus h all squared. So all we're doing, we're just simplifying the function. Watch me. 2 times x squared is 2x squared. 2 times 2hx is 4hx. 2 times h squared is h squared. We're done with the first term here. We'll move on to the next term. Negative 5 times x is negative 5x. And negative 5 times h is negative 5h. And this plus 3 is just plus 3. And then this negative 1 times 2x squared is a negative 2x squared. So now you can see why it is that I put this 1 right here. Right? Because when I'm saying this negative, I cannot say rather negative times 2x squared. That don't make no sense. It is a negative 1 times 2x squared. Then, sir, 1 is always there. If you're not seeing a number there, you can substitute a 1. But x is not 1, y is not 1, a is not 1. Right? So if I say 2, what I have right there is actually 2 times 1 or 1 times 2. because 1 times 2 is 2. Likewise, 2 times 1 is 2. So this -1 now times this -5x will give me a positive 5x. And this -1 times a positive 3 gives me a -3. Now watch me. You see, because I'm removing my f of x, it means that them 3 terms that must come out. 1, 2, 3. The same 1, 2, 3 up here so must come out. So let us check to see if it can come out. Negative 2x squared will cancel with this positive 2x squared. See here, boom, boom. Remember them last 3, something must come out, you know. So this positive 5x better cancel with something up here, boom. See here, negative 5x. So this negative 5x cancels with this positive 5x. I have one -3 here. I must have a positive 3 up top for it to cancel out. Let us check. Yeah, man, see right here, so positive 3. So the positive 3 cancel. So all I'm left with now is my chicken cream of pumpkin soup without the seasoning. I'm gonna just have a nice puree looking sort of stuff. See here, every term inside here now have the H. None of them don't have no X because you would have taken back out your X. So you have just introduced a new variable into the function. Because remember, you know, the question said as H tends to 0. But there was no H in the question before. So you will now have to put in that incremental change, which is the H. Then you recognize when H is 0, that go to 0, let us 0, let us 0, over 0. The word indeterminate comes back up. So it is indeterminate. When something is indeterminate, factorization, simplification, or rationalization. Factorization. Oh, you know, sir, H is common here, H is common here, H is common here. So when I factor out the H, see it here, so I'm going to be left with 4x, only 2h, and minus 5. Then I'm going to divide through by the h's. So now I'm having 4x plus 2h minus 5. No one can find the limit. The limit is only found at this stage. The limit is only found at this stage. Anywhere in the function I see h, I put 0. See it right here, so? So my limit now, as h tends to 0 of 4x minus 5 is going to be 4x minus 5 because this is now a constant. Oh, you know, sir, I don't have the h in here, so. So once there's no h in here, so it means it's a constant. The limit of a constant is the constant itself. So my answer is 4x minus 5. A mouthful. I'm going to ask you now to ask me your questions.
How many marks this question for you, sir?
You know, it can go anywhere between 5 and 10 marks, depending on the difficulty level. Anywhere between 5 and 10 marks. Real talk. Enough marks that. Anywhere between 5 and 10. Could be 6, could be 8, could be 10. All right. I'm going to give you an opportunity to look through the question. That's why I put it like this. And then you see number 2 in the corner down here, where I want you to follow the procedure that I have done right here. That's why I want you to see this. Follow every step that I've done and try this one on your own. I am right here. I have nowhere going. Well, the only place I'm going to go is climb up into a bed I will asleep. But I'm right here. Look through for me. Start working for me.
You can move your cursor, please. Thank you. Zoom in a little bit as well, please. Oliver not able to see clearly. Better, sure, thanks.
What here? I'm here talking to myself, guys. Forgive me. Always stay. Are you managing?
Yes, sir. Yeah, all right. Some long equation.
Hmm?
Yes, sir. All right. Some long equation. All right.
Ah ha ha ha. Yeah, man. You carry enough marks, so go on right. All right, I give you a couple more minutes to try that one for me, please. Always stay.
But team me finish.
Finish?
Thing, we're not sure.
I want you to get me, G.
As me say, I'm not sure me get 8H plus 3, I'm not sure.
Like that, me get
Sure.
No, sorry, 8
8x.
x plus 3. Yeah, because you put at the H, New Zealand and yeah.
So I'm not sure me get,
Yeah,
but
man.
it look
8,
like
8x plus 3. Yeah.
at one point I got 4x plus 3 and then I got 4x.
Check it over for me, AC. Chevy, what you get?
8x plus 3.
Okay. Simon,
So we're still right.
Tristan,
Sir, I'm get 8x plus 3.
8x plus 3 is correct. Check that for me, please. AC. There you go. 8x plus 3. Congrats. There is yet another on the board. The only way you're going to get good at this is honest to try. Remember, you know, the topic finish. I did say to you that I'm starting and finishing the topic. But because I don't want AC to say, yeah, man, I'm give you the easy one in the class and I'm going to give the hard one on the test, I'm going through as many questions as I possibly can. So as soon as I start doing the variation to the, well, you see the variation to it now. Anybody see the variation to this question? What's the variation to this question? 2018 past paper.
Wait, it's not a constant, sir.
So I'm giving you variations to the question so that anything them on them here, and they can match it up. All right. 4 minutes. So each time I'm going to give us a shorter time because it's supposed to be getting faster and better at it. 4 minutes. On the mark, gets it, go.
They're meant to make a topic here tonight because half of my brain now.
Hello. If I were you, considering that you have another half an hour plus.
I'm doing over the first question.
Okay, fair enough. Now you're speaking to me. So do over the first one. Look back at what. Remember, the race is not for the swift. It's for those who can endure to the end. So do over the first one. Any hiccups, talk to me. And then you have this one to do. I can always do these out of class. It's just exercises I'm giving in class now. All right, continue, please.
Yeah, man.
That means that you got the answer, Oliver.
Yes, sir.
All right. So tell me, what is your answer for 2018?
Six X minus 4.
That sound like Chevy.
I live for that, sir, but where me reach, I look at where I'm
It looked like I hit
projected
that.
that. Yes, sir. That's what I
All right.
where I want.
Boy, Oliver, if I were to pay you every night, you'd have brought me some. I can't even say, me I go buy one, me I go drink one beer, because me not give it to it. Very nice though, Oliver. Really, very
No,
nice.
man, I forgot beer, you can drink chubby.
They still make them something there.
Yeah, man, it's still up on the market, man.
No, when we used to like, Shandy. But Shandy
The
didn't like. But
deadly weapon.
but say them care, say Shandy come back still though, right? You know what is Shandy though?
Yeah, man.
What is it?
It's like something like lemonade and beer or something, a mixture
Yeah.
like that.
Right. But do we have something like that in the market now?
You could have said the closest thing to it would have been the sorrel beer, no?
Same way.
The
So
closest thing to it.
so what it is like the lemon is like it's more the lemon one from to me. The Shandy
Yes,
carry.
the
Yeah, man.
lemon one tastes like
Yeah.
Shandy for real.
Yeah, man. Trust me. AC. Or you say, mommy, I don't want to get frustrated. I'm in class,
No,
Are you
sir.
up?
I'm just
Are,
tired. I'm still going through number two. I'm not looking at your answer. I'm trying to figure it out.
no, and that's fine. And I appreciate that. But we're not leaving you aside. We want to hear you. We want to hear you. Simon, where you stay, Pops?
Yes, sir. I'm doing number 2018 right now.
2018 now. Tristan, where you stay? Tristan,
Sir, we get 6x minus 4.
Yeah, you're right. Very nice. Very nice. All right. So AC, we are still there with you. Chevy, you finish it now? You get the same 6x minus 4, Chef? Chevy. All right. Gone. All right. Continue working AC. Let me know where you have your hiccups. I am going to give these guys something more. All right. But I want to show you something here. 2018 past paper, and this is 2012 December. So closer questions are, in 2018, it is 3x squared minus 4x. 2012, it is 3x squared plus 4x minus 7. This one is your new classwork. So the rest of you move on for me, please. AC, if you need help, please don't hesitate to ask. Okay, so I think I may know where you're having a difficulty, AC. How is your binomial multiplication? When you're multiplying the x plus h times x plus h, what do you get?
That's not it, sir. It's just that you move faster than my brain. That's why.
Okay. So
The cursor, sir.
say it again. Oh, my cursor. Sorry. Sorry. Uh-oh.
I think I got it.
No, it's all right. I'm going to put you in a breakout room, AC, so you and I can have a little talk about the question while I have these guys work on something, but I kind of lost where I was. Finding it back now, I think. I think that's where I was. Um,
Yeah. 2012.
hmm? Yeah,
2012.
2012. Yeah, 2012. Yeah, 2012. Um, all right. I'm here. I was going to talk to AC a little bit in a separate room.
The question just vanished off the screen a while ago.
It may have. It may have. I think it was 3x squared plus 4x minus 7. What was the question before? 3x squared minus 4x?
Yes.
Right. So this new one is 3x squared plus 4x minus 7.
4x minus 7.
All
All
right.
right. Thank you very much.
All right, no problem. I have you guys
All
on this
right.
one. I'm talking to AC on the other one. All right, guys. Back at you. Back at you now. What we got for that answer?
So you can share back your screen a bit,
So
please. Yes.
we're at 23rd. Where you want to go? 28? 2018 rather?
22.
22.
Isn't 22 the one that we're supposed to be doing now, sir?
No. The one was supposed
Oh,
Yeah. 22 is not supposed to be. No, yeah, you're right. You're correct.
okay.
Hmm. Oh, well, let's see the answers. So everybody got the 6x plus 4? If you don't get it, just continue working, you know. If you don't get it, just continue working. The rest of you all right?
I got it, sir.
Very good, Simon. What about the rest of you? Got it?
Yes, sir.
Good job. Now, you see this question? None of you will get it. And I'm going to tell you why. Because there is a negative sign. They are all negative numbers. None of you will get it. Who is going to prove me wrong? On your mark, get set, go. Oliver, that goes for you, Tina Papa.
Yes, sir.
Or is it going? No answer?
Working, sir.
How is the still working AC?
6x minus 2, sir.
You're very close. And
Sir,
it
I think I'm
means,
finishing now, sir.
yes, it is where you get your answer.
Negative
Minus
6x
6.
take away 2.
Minus 6x minus
No,
2.
no, I'm asking you already, you owe us $1,000 because you said 6x. Very
Sorry,
good, guys.
sir.
Very good, guys. Very good. This is the little talk word. Very good. Negative 6x minus 2. Simon.
But sir,
Yeah.
but,
Talk to me.
oh sir, may I say rather so much work, sir, for just an answer you can predict.
Ah, I'm happy that in doing the questions over and over, and I really hope that you're not just pre the answer and telling me the answer as opposed to working the question out. Because this is what is going to happen to you. And hear me out, student. Matter of fact, I'm so happy you said, let me just talk to you. I'm doing some hosting. So I have your mid semester. You can see the question, you can pre the answer. But in pre this answer, let's believe that I am checking your every methodology, your every step. So if you pre the answer and just write down the answer, you only get 1 mark for the answer. Because for each step of the way, there are marks allocated. There are marks allocated. So if it is a 10 marker, there are marks allocated for each step of the way. If you just pre it and put on the answer, best believe you're not getting 10 out of 10. I see the answer and the answer is right, you're getting the answer mark 1 out of 10. And I'm happy that you're able to pre it, because when I move to the other aspect of differentiation, I want you to also be able to pre it. It's just like what I said to Oliver just now. Check your answer and don't ask me, check your answer. And he was able to check his answer by substituting the value of A and B and then performing the operation once more to the left and right, and he got the same answers. That's how you take the answer. So very good to know that you can pre, but also very, very, very important that you always show your working, because full marks will not be awarded if your work is not shown. All right, very important. So I'm happy. It's just like how Sir show you how to pre the limits as you go to infinity, whether or not you have the zero and then something here. Yeah, man. Sir wanted you to pre this one too, but Sir wasn't going to tell you. Sir wanted you to pre this one. So that's very nice. Very, very nice. Question. Is there anyone in the class that don't see the pre-ments yet? Yeah? No? Oh. Let me talk to me, man. Are you hearing me?
Sir, you say if there is anybody, which means if there is nobody, nobody will answer.
Hey, somebody said, they don't know if they mute and nobody not talk to me. When they say, yeah, man, sir, we get it.
No good so far, man. No good so
Yeah,
far,
man.
man.
Me not hear nobody not inhale or exhale. Only just stand still. When the clear the throat one time, me not see the dead.
But sometimes, you know, you see the way you ask Daniel say it, you know, is the way the question asked, you know.
Nah. Say, yeah, man, sir, we catch it, man. say something that me know say the dead man. Or clear your throat.
But sir, if we not hear you, we're gonna tell us that we not hear you.
All right.
And if
You
you
know,
pause too long,
Arsenal,
we're gonna say, sir, if you're speaking, we not hear
Arsenal,
you.
you know again though, again play the silent game for one of them nights, yeah. And I bet you not gonna say, I was sir there. Sir got sir.
Only
And him
but
gone.
tired with sir.
Early Christmas carol, silent
Or
night.
the same way so. Same way so. They go sit down and they go hear not come, they go say, watch them. Good day. Anyway, come. Very nice.
You call off your phone, sir. So
Same way so I know me go answer the phone and don't say nothing either. Just we could go on. All right. Very nice. I don't think I need to do anything else. Oh yes, actually I do. All right, let me see if because sometimes light is just not there are sometimes shades of gray. Sometimes yeah ma'am, you want you look on this and you tell me about the answer straight up.
50 of the shades, sir. We're not seeing your screen.
I know, because teacher just uh-oh, what did I do? Yeah, I did the right thing. Teacher just some final question for the night. And I know why I'm saying final question for the night because this will take us up to our class time. I don't want anybody to tell me how wicked I am.
Can you know the question about my show?
No man. No man.
Disclaimer will come up. Don't want anybody to say, sir, I know me at that.
No, absolutely not. I'm just speaking about AC. All right, let's go. All right, let's go. So I want you to differentiate, and this is a challenge question. You guys, I know, understand the topic now. I know you understand the topic now. Here goes a challenge question. And I want you to try as best as possible. Now, remember, this question is a question on algebra. It's after you would have applied the f of x plus h minus f of x over h, the limit as h tends to 0 of f of x plus h minus f of x all over h, the differentiation from first principles ends right there. What matters now is your algebraic skills to bring it to a final answer. That's what matters. So I want you to be very patient. I expect to come in and help you with this one. This one is a quotient one. I expect to come in to help you with this. But I want to see how far you can go with this question. Don't worry about it. I will never throw you out into the deep without some life support. All right? See how far you can get to this one. If you get it to the end, hooray. If not, not a problem. On your mark, get set, go. How far are we now on that one?
Trying to figure it out.
If you understood the first one, the same procedure that we're doing. The limit as a tends to 0 of f of x plus a. Every time you call a x, you put a x plus h, and you enclose it in parentheses. Then you're going to minus all the f of x
Sure,
over h. Yes, love.
sure.
Hmm.
Knowing that this is a fraction, right? And it's dividing. Am I multiplying for the difference?
Multiplying what?
So here's what I have. I start writing in pencil because I'm not sure. So the question that we got, 5x minus 1 over 2x plus 3. Where we have x, we put h. My next step from that,
Wherever you have x, you're going to put x plus h, not just h.
x plus h. Well, that don't look correct then, but let me see.
But it's not h alone, you put it on the first one. After that.
I'll put plus h in the first one.
X plus h.
Oh,
5 open bracket x plus h. Similar to what it is that you did in the first one. In the other type. You remember the formulation said, the limit as h tends to 0 of f of x plus h minus f of x. So you have to add the increments first. So it's going to be 5 times x plus h minus 1 over 2 times x plus h minus 1. Look at what I have on screen. Because it is still f of x plus h minus f of x all over h.
and then you'd have 5xh minus 1.
No, ma'am. We'll have 5x plus 5h minus 1.
Okay.
Remember, 5 is going to govern everything in the parentheses. So you're distributing the 5 over the x and over the h. When you asked me if you were going to do some multiplication, I became very excited because I was wondering what it is that you're talking about. And then when you asked the question, I was like, oh, no, that's not what she was referring to. Hold on one second.
So I was thinking along this line. I said because, but then is the x plus h true male?
Okay, I'm happy for that. So what I'm doing, this division of the h down there, I'm just converting it to a multiplication. So I just have it now as 1 over h. Is what I'm saying here? So dividing by h is the same thing as multiplying by 1 over h.
Wait, the inverse.
It's not really an inverse in a Papa. Look at this. Where's the h? Is the h in the numerator or the denominator?
Denominator.
Where's the h right here, sir? Denominator. Right. So there's an imaginary 1 up here. So there's a 1 over this h. So I'm just pulling it out as 1 over h. Right? And then this is what I'm gonna do. And then this is what I'm gonna do thereafter. Matter of fact, I'm not even doing the multiplication, the expansion. I'm looking here to see this for my LCM. Now remember, if you have 1 over 2 plus 3 over 5, in that case, your LCM is going to be 10. 5 times 2. Because there's nothing common. one is not a factor of the other. If I had 1 over 2 plus 1 over 4, 2 is a factor of 4. So I'm not going to say 2 times 4 to give me 8. I'm going to use a 4. But once 1 is not a factor, you can just go ahead and multiply both. So if I have 1 over 3 plus 1 over 2, my LCM is going to be 6 because 1 is not a factor of the other. All right? So this is a spotlight. This denominator is going to be multiplied by this one here to give me this denominator here. And then I'm going to ask a question. This into all of this will go 2x plus 3 times. And this 2x plus 3 times the numerator is 2x plus 3 times the numerator. Minus. All of this, this 2x plus 3 into all of this goes all of this up to something here. 2 times x plus h plus 3 times. And you multiply it by 5x minus 1. So it's going to be 5x minus 1 times it, 2x, all of that ugly thing. And I'm still having the 1 over h. I know I'm going through this quickly. I'll send it off to you so you can have a look at it. But you have to promise me that you're going to go through this. And then I am going to say, I'm going to do some distribution now of the inside, which is what AC and I were talking about earlier. 5 times x is 5x. 5 times h is 5h. And I have the 1 plus minus 1. 2 times x is 2x. And 2 times h is 2h plus 3. And then now, I am going to distribute this over this to give me all of this. 2x times 5x is going to be 10x squared. 2x times 5h, 2 times 5 is 10xh, 10xh. 2x times negative 1 is negative 2x. Boom. And then 3 times 5x is 15x, see right here, sir? And then 3 times 5h is going to be plus 15h, see right here, sir? And then 3 times negative 1 is negative 3, right here, sir? Minus sign still, minus sign here. 5x times 2x is 10x squared, see right here, sir? And 5x times 2h is going to be 10xh, see right here, sir? And 5x times 3 is going to be 15x, right here, sir? Negative 1 times 2 is negative 2x. So, negative 1 times 2h is going to be negative 2h. Right? Negative 1 times a positive 3 is negative 3. Right here, so. Care about the same 1 over h. Care about the same denominator, not changing. Then now I'm going to remove my parentheses. Everything in the first parenthesis will remain the same. See here? Everything in the first parenthesis will remain the same because it's not being affected by a negative sign. Like this one is. This one here now is going to be negative 1. You notice this one, I don't put the 1 here, but there's an imaginary 1. Negative 1 times 10x squared is negative 10x squared. Negative 1 times a positive 10xh becomes a negative 10xh. And technically, all of these, the signs are just going to change. So this is positive, it becomes negative. Negative becomes positive. And all of these here, 1, 2, 3, 4, 5, 6 terms must cancel out. See here? This cancel out something. 1, 2, all the terms with the x's and the constant will go. So I'm going to have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, right? So all the terms with the x is going to go. This term is the only one that is going to remain on this side. All right? I'm going to cancel all of those. I'm just going to be left with 15h plus 2h. There's 2h on this side and 15h on this side. So everything with the x and h will go. Only the h is going to remain. And then I can't do anything because this has to cancel out. So I have to factorize up here first. So when I factorize up there, Well, what I did was to add, I put an extra line by adding. So we get 17 here. So when I put the 15 and the 2, I get 17h. Now I'm canceling these h's. Remember, I have to cancel the h because if I don't cancel the h, as h tends to 0, I'm going to have a 0 in my denominator. And you and I jolly well know that you can't have a 0 existing in the denominator. You and I know you can't have a 0 existing in the denominator. So I'm just going to have all of this. And this is what is going to work out to be the limits now. As h tends to 0, again substitute 0 into the function. Here so, 0 come right here so. Boom. And when 0 come right here so, in this bracket I just going to have x plus 3. No, like I'm going to have 2 times x is 2x and 2 times 0 is 0. So I'm just going to have the 2x here plus 3. See here, 2x plus 3 and this 2x plus 3 here. And 2x plus 3 times 2x plus 3 is going to be 2x plus 3 squared. And then your answer is going to be 17 over 2x plus 3 all squared. I know this is a lot, but don't worry about it. What I wanted to have completed tonight, I did. I'm going to send off this quotient one to you a little later. I'm just going to take a little relax, sit down and maybe just a quick sleep and then get up tonight and send off for you. But you did well. I'm happy that you all know. I can safely say those of you who are in class, there are a few students absent, but I can safely say that all present understands what we did in class tonight, and that's very good. Of course, maybe with the exception of this because this was at the tail end of the session. But as per usual, big up yourself. I'll send it off. We'll have conversations on this. Let me know from now. Do you want the mid-semester Tuesday or Thursday next week?
Thursday.
Is that the mind of the class?
Yes, sir.
All right. Big up on yourself.
So remember to send the notes on us, sir.
I'm going to send this to man. I'm going to send this to you. All right. All the best, guys. Take care.
All right.
Sir, have a good night.